Starting example 4 here, the pH of a substance equals negative log of H plus, where H plus is the concentration of hydrogen ions. The concentration of hydrogen ions for ammonia, which is this, is 10 to the negative 11th power. The concentration of hydrogen ions for vinegar here is 6.3 times 10 to the negative 3rd power. What is the difference in pH levels of ammonia and vinegar? So we're going to subtract these to find the difference. Difference means subtract. So I'm going to start off with negative log of my concentration of ammonia, which is H plus sub A, minus my log of vinegar. So minus a negative means we're going to add log H plus sub V. I'm going to rewrite this real quick just so we have our positive logarithm in the front, which is going to end up being our vinegar, just to make it a little bit easier to look at. So now I have log of our concentration of hydrogen ions for vinegar minus log of our concentration of hydrogen ions for ammonia. Now we know what some of these values actually are. So if we look here, it tells us that ammonia is 10 to the negative 11th power. So instead of having H plus A, we know that that value is actually just 10 to the negative 11th power. Instead of having H plus V here, we know that value. So I'm going to substitute that in as well. Log of 6.3 times 10 to the negative 3rd power. And then we're subtracting here. Drop that down. I'm going to simplify a couple things here. First of all, we have multiplication inside our logarithm. So I can rewrite that as two separate logs as long as I keep my base. And my base here, because there isn't one, is 10. Okay, when they don't show us, it's 10. Log of 6.3. Remember, when we multiply within, we add to make it a separate logarithm to expand it. Log base 10 of 10 to the negative 3rd power minus log base 10 to the negative 11th power. And the reason I did that is because we want to simplify this the best that we can before we type it in, because otherwise it gets to be a little bit hectic and there's a very good chance that we're going to mess some things up. So our exponents we can swing to the front using that product property. It's going to give me log 6.3 minus 3 log of 10. And then when we take negative 11 times this negative here, we get minus negative 11. Two negatives make a positive times log base 10. We also know that log base 10 is just 1. Log base 10 is just 1. So the simplified logarithmic form of this is log of 6.3 minus 3 plus 11, or log 6.3 plus 8. And that's fine and dandy, but not super helpful. So when we're asked what is the difference in pH levels, okay, remember pH is our logarithm. So I'm going to go ahead and figure out what that is. So log 6.3, don't forget to close your parentheses, plus 8 gives me approximately 8.799, so 8.8. Okay, and that's going to be my pH level. About 8.8. Recap here. Logarithms and exponents have corresponding properties, and that's because logarithms themselves are exponents. They're what we use to solve problems that have variables in our exponents. We can't do that without switching them to logarithms. So their properties are very similar. An exponential function is a function with the general form y equals a times b to the x power. In an exponential function, the base b is a constant. The exponent x is the independent variable, with domain the set of all real numbers. So we can plug any number we want to into x, any real number into x, and our base b is a constant. That means it can never be a variable. It always has to be 5 or 2/3 or some concrete variable, a constant. I'm going to flip over here to your assignment. Again, you don't have to work on that. We're going to work on it in class on Monday, but it's there for you just in case.